All right, so for today's deep dive, let's talk about a logistical nightmare. It's that problem of trying to get a high-quality video signal from a computer to a screen that's just a bit too far away.
Right. Your standard copper cable, like an HDMI or DVI, is great for the living room, but physics just gets in the way pretty fast.
And we're not talking about, a little bit static. With digital video, you get these weird green sparkles. The signal just drops entirely. A black screen.
Total signal loss.
Exactly. So how do massive places like airports or hospitals or stadiums handle this? That's where we get to the Kramer 610R-T.
It's a very specialized piece of hardware that solves this very specific problem.
It is. So our mission is to explore how this device bridges that physical gap, especially when the stakes are really high, like in aviation or healthcare.
Well, bridge is the perfect word for it, because the 610 isn't really one box, it's a set.
It's a pair, right?
A pair. You have the 610T, that's the transmitter, and the 610R, the receiver. And the bridge between them isn't copper, it's fiber optic cable.
And specifically, multi-mode fiber. That's a key distinction, I think. We're not talking about the kind of single-mode fiber that runs for miles under the ocean.
No, that would be serious overkill. Multi-mode is really optimized for what we call building scale distances.
And the range on this system it's huge.
That's up to 400 meters, so that's about 1,300 feet.
That is massive. You could have a server in a secure room in a basement and the display in a penthouse, and they'd act like they're connected with a 3-foot cable.
And crucially, with no compression or signal loss, it pushes a resolution of up to 1920 by 1200 at 60 hertzes.
With a data rate of nearly 5 gigabits per second.
Yeah, trying to do that over a quarter mile of copper wire is, well, it's basically impossible.
But moving to fiber isn't just about the distance, is it? It also changes the entire safety profile of an installation.
Oh, fundamentally. You're sending light down the line, not electricity. So you get rid of all that electromagnetic interference that copper generates.
Yeah.
Exactly. And that's why this unit carries the IEC 6060112 certification.
Which is a medical standard. It's for electromagnetic compatibility.
Mm-hmm.
So that explains why you'd find these in an operating room. You can't have the video cable from a medical display messing with a heart monitor.
Absolutely not. Safety is everything there. But, there is a trade-off with this device that really defines who it's for.
Okay.
If you read the specs, it states very clearly, not HDCP compliant.
Oh, and that's the copy protection.
Yeah.
So, no Netflix, no Blu-rays.
None of it. You just get a black screen. The handshake for that encrypted content just isn't built into it.
So this is strictly for professional data streams.
That's right. We're talking flight traffic control maps, medical imaging, data for banking, digital signage in a stadium, just raw information.
Honestly, for those uses, cutting out the HDCP probably makes the connection simpler and more reliable.
It does. It simplifies the whole signal chain.
Speaking of the signal chain, we should probably touch on the ED capture feature.
Oh, for sure. It's a standard feature in Pro AV, but it's absolutely necessary here. The transmitter basically clones the monitor's information. Its ID card, you could say.
So the computer at the source thinks the monitor is plugged directly into it, even from 400 meters away.
Exactly. It prevents the PC from, defaulting to a low resolution because it can't see the screen. It guarantees a stable picture.
It really hammers home that while we all focus on the big, flashy screens, it's the invisible infrastructure in the walls that's doing all the heavy lifting. But looking at the specs here, the 610R-T, it maxes out at 1920 by 1200.
Which is more or less standard HD.
Right. And we are moving so fast into a 4K, even an 8K world. So if it takes this much specialized tech just to move an HD signal 400 meters...
The infrastructure challenges for the next generation of displays are going to be immense. The bandwidth we'll need is it's going to be astronomical.
So next time you see a perfectly crisp 4K sign in an airport, just think about the plumbing behind that wall.
And how much more complex and expensive it's becoming to get all those pixels where they need to go.
The engineering puzzle just never ends.
It never does.
Thanks for deep diving with us. Catch you on the next one.